All right, so let's talk about something called hydrostatic pressure. So, put simply, hydrostatic pressure is the pressure that a fluid exerts on an object. So, for example, if you were to take something that was, common, if I were to take an empty can of soda and I seal the top and I pull a vacuum, right, and I suck all the air out of the can is going to be crushed. And so that's because the air is exerting a pressure on the object. In this case, it's the can, and so the can can't support that pressure, and so the can gets crushed. In this case right here, we have three different submarines here, and so the hydrostatic pressure in this case is going to be the water, which is exerting a pressure on the walls of the submarine, right? And so there's a couple of different points about hydrostatic pressure that are kind of important that I wanted to point out. Um, so in this case, obviously pressure is going to be equal to the force per unit area. So that's let's see. Let me find a space to write this in. Pick a color. Here we go. So pressure is going to be equal to the force exerted over a given area. Okay, so that's sort of the first point here. The second point is the fact that as we, I should say, the pressure is totally dependent on well, actually, in this case, it would be totally dependent. The pressure that is exerted on the submarines here is dependent on the depth, right? So this case, this would be, so if you look at the formula here and this over here, so this would be say H1, and this would be H2 for this big green submarine over here. And so obviously as we increase H, since gravity is constant, the density of the fluid, whether it's water or air or whatever, is going to be constant, obviously. So the only thing that's going to change the hydrostatic pressure in this case is H, and so it varies linearly. And in this case, when we're talking about the submarines, as the submarines descend, as they increase their depth, as H increases, the hydrostatic pressure is going to increase, and it varies linearly. The third point here is the fact that the pressure is independent of an object's area and size, right? So if one of these little white submarines here descended to the same depth as this big green submarine here, the hydrostatic pressure would be exactly the same on one of these white submarines as would be the same as the big green submarine here, right? So it's independent of area as well as size. The two other points are a little bit more advanced here. It says that the pressure at a point has the same magnitude in all directions. That's sort of a duh. And the pressure is exerted normal to a surface regardless of its shape. And that's obviously because the fluid is incapable of supporting shear stress, right? Because it's, anyway. So let's see if I wanted to see if I covered everything here. Also, I just wanted to point out that the hydrostatic pressure that the first submarine here is the hydrostatic pressure that is exerted on it is going to be the same as the submarine number 2 over here. That's because they're at the same depth, right? And so pressure is only affected obviously if the density of the fluid is constant as well as gravity. It's only affected by this H over here, right? So in this case, this would be the depth of the submarines, right? So hopefully this video clarified some stuff. We're going to do a lot of problems in fluid mechanics, in particular calculating pressures and that sort of thing. So thanks for watching. Hopefully this helped, and we will see you all in the next video.